Types of coordinates by cruise, a spatial.
Okay, in the first slide we have an objective, and the first explain the fundamental differences between coordinate systems and highlight the importance of choosing the right coordinate systems for each application. Right? Introduction to coordinates. In the initial of the era, the circular plate indicating the positions of the constellations observed on the night of January 3 or 4, 650 before Christ is around 90 B. The celestial planisphere is divided into 8 parts, in which are distributed. In this figure, we see the reference the peoples in this area and the stars for segments. Okay, and we have two uh, old model named geocentric. Okay, created for Aristotle and Claudio Ptolemaeus. In actually we have the true model named heliocentric with the sun in centric this model and proposed for Copernicus and Kepler, Galileo, and Isaac Newton too. Radar coordinate systems and frames. This topic is about actually, and we have, for example, global frame, utility 3 coordinates, and X, Y, and Z. Body frame, utility the body, and the same coordinate for the body principal and the body second. We have mountain frame, utility is looking for these coordinates, and sensor frame too. For global coordinate reference frame, we have a ECEF named or century or fixed. Okay, in this topic we have North Pole, line equator, and prime meridian for X, Y, and Z, and geographic coordinate systems for utility, the measurements for latitude and longitude, the coordinates in these systems, and local coordinate systems. This is more simple. Name it Cartesian coordinate systems, utility 3 axis for 3 dimensions, or 2 axes for 2 dimensions. For 2 dimensions we have X and Y, or 3 dimensions we have X, Y, and Z. Name it north is down, north for axis X, east for axis Y, and down for axis Z. If not utility down, we utility up, okay? Down and up. In this topic is named East North Earth up. The next figure for representations these coordinates in the global. In this example, we have latitude and longitude for find this point in surface the Earth, and we have two other coordinates named spherical coordinate systems for azimuth and elevations, orientations, positions, and coordinate conventions. In this topic, we say the point rotations are frame rotations. The point rotations, the frame is static, but in frame rotations, the point is static. For the curiosity, and we have variables x, y, and z. Euler Angles named the rho, p, and yaw in this limit for the angles. Coordinate systems for modeling. And the first we have ECI coordinates named Earth-centered inertia. And in this topic, the coordinate is static, is not rotations with Earth. Okay, system does not rotate with the Earth, making it is simple to model the motions of satellites and the other celestial bodies in space. But we have two Earth-centered, Earth-fixed coordinate systems. And in this part, we have a movement and systems other to right hand. Okay, the right hand, three axes, perfect. Making it ideal for mapping, navigations and positions tasks on the planet. ECEF coordinates change with time for a given point on the Earth's surface due to Earth's rotations, which is useful for real-time applications like GPS or global position systems. In this image, we have an example for ECEF coordination. Note these pictures, we have a range and elevations and azimuth angle. And two, we have a LVLH, named local, vertical, local, horizontal. For the axis is centered in the body, secondary. In this case, we have a satellite. And the first axis named S or a long track, W named cross track, and R named radial. Okay, and the radial is this line for center orbs or first body, and the line is the satellite to center Earth is named Niger, and the satellite to space named Niger or Zenith. Okay, and finally spherical coordinates. In this figure, we have azimuth and elevations. For combination of these two angles, we have a vector for and find this point. Okay, and azimuth is party is the axis x, and coverage this plane. Elevations this party I in this plane. Okay, see the plane IZ plane. Okay, and this vector is the image for the vector principal. Okay, and finally we have these three combinations for azimuth, elevations, and range. This complement, or excuse me, and this measurement, or this vector. Note: geodetic latitude ellipsis is more important than geocentric latitude spherical because this is a real or approximate a real model of the Earth, and spherical is not approximate the real model of the Earth. Okay, and two, Jota 2000 for January 1, 2000 years and 12 hours AM TTR and Earth time, terrestrial time. Excuse me, this is our we are. And when someone says that an orbital is given in Jota 2000 coordinates, it is meant that the vectors, positions, and velocity were expressed relative to the Earth's axis at the instant, and the 1 month 1 years 2000. Okay, before considering precisions and notations. Very good. This is end. Thanks for coming. Thanks for watching, and see you.
Sign up for more information. Turn on notifications to stay updated.